Hello, Calculus crew. Subbing in today is Mr. Brzee. We're going to take a look at some optimization problems, part two. So the idea that you guys were looking at in last lesson was the idea of saying that if we can find the derivative of any function and let that zero, we can either find if it's a max or a min. So that's kind of the goal today, is to build our original equation, be able to set it equal to zero, take the derivative, set it equal to zero, and then figure out where those critical points are. So we're going to try to get that. So an island 4 miles up the river. So this is 4 miles from here to here. And 1 mile from shore is going to be connected. It costs $30,000 per mile to lay a cable underground. So the idea here is this is my underground this direction, and underwater is this direction. And it costs $50,000 to lay cable underwater. What is the least expensive way to lay a line? So we're going to look at the idea of we're going to try to minimize our cost. So first of all, we have to make an equation. So the cost of this is going to be two parts: cost of the underground plus the cost under the underwater. So here's the hard part. We need to figure out how far down this corridor do we want to go for the underground, and then the rest has to be underwater. So we have to figure that out. So what we're going to do is we're going to let this distance be x. Okay? That's going to be our unknown, is how far down the river or the shoreline do I need to be so it keeps the minimum cost. So we have this distance. So if I'm looking at this distance, this has to be 4 minus x. So that would be this distance from here to here. Okay? So the question is now, how do we find how much underwater are we looking at? Well, if we look at this is a right angle triangle, so we can use Pythagorean theorem. So if I was looking at I got to find my hypotenuse here. So my hypotenuse is going to be, if I was going to find c as my hypotenuse, that would be c squared equals x squared plus 1 squared, which is 1. And if I do the square root of that, that would be x squared plus 1. So this piece here, this distance, is going to be that length from underwater here. So now we just got to figure out, okay, build our cost equation. Well, if this is the distance underground, it costs $30,000 underground. That would be 30,000 4 minus x plus the underwater. Well, that distance is x squared plus 1, and we're going to multiply it by 50,000. So let's call that c of x. Okay. And then from there, we're going to do a little bit of getting these in the right form so that we can do the derivative. So if I was doing this, I might want to expand this out, or the other way. So that would be 120,000 minus 30,000x. And we can treat this like a half. All right, so this, we're gonna set this up, so this is 50,000 x squared plus 1 to the 1/2. All right, now we're gonna do the derivative. Derivative of a constant is nothing, derivative of that is just 30,000x. We bring the 1/2 out front, so that would be 25,000. Bracket x squared plus 1. The exponent reduces by 1, so that's a -1/2, times the derivative of the inside, which is 2x. All right, now we're going to tidy this up. All right, I have, if I combine 25,000 and 2x, that is 50,000 x over, and we can put this back as x squared plus 1 with the square root. All right, now I'm going to set this as a 0 because we're going to find the minimum or maximum. So 0 equals that's a negative there. Bring over the 30,000, so that becomes positive 30,000. So, sorry, I made a mistake. When I do the derivative, that x is gone, my fault. All right, and so we're just doing some algebra to figure out what x is. To get rid of this, I can multiply both sides by x squared plus 1. All right, and then those cancel out. So now I'm left with x squared plus 1 equals 50,000 x. All right, I'm going to reduce these, so I'm going to divide by 10,000. So this ends up being 3x squared plus 1 equals 5x. Now we're going to try and get rid of some stuff. Well, here I want to get rid of the square root. So let's square both pieces. Actually, we have to square, sorry, my fault. I have to square both pieces here and both pieces here. So I square both sides. Let me make this a little bit easier. This is be 9, and then when you square root a square, square root goes away, and that's 25x squared. Okay, I'm going to expand this. So 9x squared plus 9 equals 25x squared. I'm going to subtract both sides. All right, so I'm left with 9 equals 16x squared. Sorry, if you have to take a pause. All right, divide both sides by 16. So 9 over 16 equals x squared. And then if I can do the square root, all right, I get positive negative 3/4 equals x. So this is our critical point for x. Now, for this question, the negative 3/4 doesn't make sense because it's not a length. So we can ignore x equals negative 3/4. Okay, so this is the only we're looking for. So now to find that point, we just have to put this into C. So what does that look like? All right, I'm gonna put in 3/4 in for C. I'm gonna change it to 0.75. All right. All right, so my initial function was 30,000 4 minus x plus 50,000 x squared plus 1. All right. So I'm going to put those in. So I'm going to allow myself a little bit more room here. So if you did that, this number here should be 97,500 plus, and if I did 0.75 squared plus 1, did the square root of it, times by 500. So if I was doing that on my calculator, I could think of this as 5,000 times the square root of bracket 0.75 squared plus 1, close the bracket, you'll get that 62,500. And if I add that up, that would get me my minimum cost. Okay, so we also have to test the endpoints. All right, so our function is only valid from 0 to 4, right? I can't have, if I went back up to here, I can't have x being any bigger than 4 here. So my endpoint is at 0. So if I was doing C at 0, that would be all if it's on all underground. So this would be 30,000 times 4 plus 50,000. And I'm putting that as 1 squared plus 1, and you would get 170,000. No, I take that back, that should have been 0 squared. And if I was testing at C at 4, so that would be, if I put 0 in for, or 4 into x, I make that 0 plus that. You would see that that is 206,155.28. So I can put that in my calculator. So if I'm looking at this, that's my minimum cost, that's the smallest cost. So if I'm looking at this, answer the question, what's the least way of laying the cable? Well, if we went back to our question here, we wanted to know how much was underground and how much would be under the water. So if I was looking at my therefore sentence, underground would be, is my 4 minus 0.75. All right, because remember our X is that, and our underground up here is 4 minus X, and our underwater distance was X squared plus 1. So I can put in 0.75 squared plus 1. That would be 1.25 minus. All right, so there you go. All right, the second question talks about a Norman window, and basically it's a rectangle with a semicircle on top. So what we're going to try to do is determine the dimensions of the normal window so that it would let in the maximum amount of light. So we're looking for a maximum, okay? And we want to know when the perimeter is equal to 10 meters. So what we're going to do is we're going to try to build an equation that relates to the area of this shape. So the question is, what do we know? Well, if we were looking at the perimeter of this shape, all right, we know that that is the radius. And what we're going to do is we're going to try to figure out what X is. We're going to figure out how far up or down this is. So I've got a semicircle for my perimeter plus 2 X's, right? An X there, an X there. And this distance from here to here would be 2R because the radius is 1 there. That has to be 2R there. So that's what I have. So we also know that a semicircle, all right, circumference is 2 pi r. Well, for that, we would divide that by 2. So we've got a perimeter, right? Semicircle is just pi r, because we divided that by 2, plus 2x plus 2r. And we know that this is 10. So the perimeter of that shape is that. So what we're going to do is we're going to isolate x. So we're going to move everything away from x here. So to do that, here I'm going to subtract 2r, subtract pi r, bring that over to the right, to the left side. 10 equals, or 10 minus pi r minus 2r equals 2x. And then I can divide everything by 2. So I'm left with x equals 5 minus pi over 2r minus r. So that is the expression that we're going to use for x to help us with finding the area. All right, so looking at this, all right, we've got the area of the semicircle, plus the area of the rectangle. Okay, and we're going to relate this step. We will relate to x eventually. So area of semicircle, okay. Pi r squared is the big circle, so we're going to do pi r squared divide, or half pi r squared plus 2rx. So if I was looking at my rectangle, think of this as my length and width. All right, length is 2r, my width is w. And then what we're going to do is we're going to replace x with this expression that we've created. So now we have an expression with just r. So the area with respect to r would be 1/2 pi r squared plus 2r, and then I'm going to put everything in here, 5 minus pi over 2 r minus r. Okay, I'm going to expand this a little bit. I'm going to expand this into this, this into this, this into this. Two r times 5 is 10r. 2 times 1/2 pi, that would be just pi r, I believe. No, pi r squared minus 2r squared. Okay, and we're going to put a little caveat here. R has to be greater than 0. All right, doesn't make sense to have a radius that's less than 0 because it's impossible. Okay, so now we just want to find the derivative, and then we're going to set it equal to 0. So derivative of that, so that would be 2 comes out front, so that would be just 2 pi r. Derivative of that is just 10. The derivative of that is minus 2 pi r. Oh, this one's just pi r. And the derivative of that is 4r. All right. I'm going to set that equal to 0. And so pi r plus 10 minus 2 pi r minus 4r. What we're going to do is try to collect some like terms. So this has an r in it, this has an r in it, this has an r in it. So we're going to kind of group those together. So 10, and then if I take out an r of each of those, pi minus 2 pi minus 4. And if I simplify that, that just becomes minus pi minus 4. Maybe we take a negative out of that one too. So 10 minus r pi plus 4. All right. And then, so think about that still as multiplication. So we're going to add both sides. All right, so r pi over 4 equals 10, and then I'm going to divide both sides by pi over 4, pi plus 4. Okay, and then from there, I can just approximate the solution. So approximately, that is roughly 1.40 meters. So if I was putting that in my calculator, I may have to do 10 divided by bracket pi plus 4. You get that. So that tells us that we know that this is our critical point. All right. Then we have to think about this as we have to make sure, are we, what is the second derivative? So we got to think of it are we making a maximum? So I might have to do the double derivative. So what I'm going to do is I'm taking the derivative of the first derivative. Actually, I could probably pull it from, yeah, we could. So it was right. So the derivative of all right, so simple derivative, that's just pi, that one's gone, and that one's just 4. And so this is minus pi minus 4, and if we have, remember we have to put our critical point in, so if we put our critical point in, all right, so we put in 1.4, it's that, so that means that it's less than 0. This is a constant. Okay, so that means this is concave down, so it's always decreasing. So this is a max. Since it's less than 0, we have a max. So we know that that is a max no matter what. So now we just have to figure out what is x. Well, we know what our radius has to be. So therefore, find the dimensions of the window. Well, our radius is going to be approximately 1.4 meters. And we need to find what x is. So we would go back to your perimeter question, your perimeter equation. So our x, if we take this equation, all right, so x equals 5 minus pi over 2 r minus r, okay, and I can just put that in. I can put in 1.4 minus 1.4. All right, you would actually see, if I did that math, this would actually be the same amount. So if I was going back to my window here, okay, and I didn't draw this very accurately, all right, my radius is 1.4 from there to there, and this is my x. So my x is 1.4, and this distance here would be 2x, which is actually 2.8 meters. So I'm going to write it there for a sentence. So just kind of summarize what we did. The diameter has to be 2.8 meters straight across, and this distance here has to be 1.4 meters. Okay? All right, last question. We got a can that's manufactured to hold 1.5 liters of oil. Find the radius of the can that minimizes the cost. So again, we're going to find the derivatives that equal 0, figure out those critical points. Common thing here we have to think about is this conversion. So we're going to use this conversion based on the dimensions of the cylinder. So we got a can. All right, and we're looking at the volume of this can. So we got a volume, and if I went back to grade 9, that's the volume of the can. Okay, we know that this is the radius, we know that this is the height. Okay, and we know that our volume is 1.5 liters, and if I convert that, that would be 1,500 centimeters cubed. So what we're going to do is we're going to use this quantity to build an equation that represents, that compares the, an expression for the height. So we're going to plug those in. So 1,500 equals pi r squared h. So we're going to solve for h. We're going to divide both sides by pi r squared. All right. So we're going to use that to plug into our surface area question. So we know that the surface area of a can is 2 pi r squared, the two circles on the end, plus 2 pi rh. So that's something that this is given, okay? So just like we did with the previous question, we're going to sub in this h into the equation to just get one variable representing the surface area. So I've got my area of r, so 2 pi r squared plus 2 pi r, and I'm going to put in that 1,500 pi r squared. All right, we're going to do a little math. We're going to try to collect like terms. So 2 times 1,500 is 3,000. All right, those pi's are going to cancel out, and I'm left with 1r to the -1, right? And then I'm going to do the derivative. And we're going to set it equal to 0. So derivative of that would be 4 pi r plus -1, because we're bringing the negative out from times 3,000 r to the -2. All right, we're going to set that equal to 0. Simplify this, -3,000 r to -2. Okay. So let's bring 1 over to the other side. I'm going to bring over the -3,000 term over. That makes that positive. All right. Maybe we multiply both. We're trying to get all the r's on one side of the equation. So if I multiply it by r squared, if I add those exponents, that gets me 0. All right, and then I can solve for r. I could do the cube root. Of that, and I can put that in my calculator just like this. I can find so I can do 3 like that, 3,000 divided by 4 divided by pi. You should get 1 point. Oh, I screwed up on that. So I can do bracket 3,000 divided by 4 divided by pi. Close the bracket, and I should get about 6.2. So make sure when you're underneath the square root, make sure you use a bracket so that catches that. You get 6.2 centimeters. Okay, then I gotta do the second derivative to check to see if it's a max. So we wanna know if our minimum, we're hoping that our double derivative is greater than 0. So we're hoping that's the case. So if I was going back to my original derivative function, that was a prime of r is 4 pi r minus 3000 r negative 2. So we're going to do the derivative of that one. Okay. Derivative of that is just 4 pi. And then that becomes out front. So it's minus negative 2 times 3000 r to the negative 3. Four pi, and that would be plus 3000, and then that would be to the cube. So now we're just going to put our r in that we're going to check. Well, guess what happens? This is definitely greater than 0. All right, so therefore, our critical point of r equals 6.2. That is a minimum. All right, so from there, the radius should be 6.2 centimeters to minimize the cost of the metal. Done. All right, give the practice a go, see how it goes.